Have you ever driven down a sun-baked road and seen a shimmering pool of water that vanishes as you approach? Or watched a ship appear to float above the horizon? These aren't hallucinations, but truly observable physical phenomena called mirages. But what exactly are they? A mirage is an optical phenomenon caused by the bending of light rays as they pass through layers of air at different temperatures, resulting in the appearance of displaced or distorted images of distant objects. Let us begin with a fundamental principle. Light travels in a straight line through any homogeneous medium. But as soon as light enters a non-uniform or heterogeneous medium, such as our atmosphere with its temperature and density gradients, its path bends, a process governed by Snell's law. In 1 sine theta, 1 equals, and 2 sine theta, 2. An inferior mirage is what you see on a blazing summer road. Asphalt can reach 60 degrees Celsius, but a meter above, the air is only 35 degrees Celsius. This large temperature difference means the air near the surface is less dense, lowering its refractive index compared to the cooler air above. When skylight enters this gradient, it bends downward. Your eye receives light coming from near the ground. The superior mirage, in contrast, most often appears over cold water and ice, such as in the Arctic and Antarctic, when warmer air floats above colder surface air. This temperature inversion bends light rays upward. As a result, a distant ship or island appears lifted and can sometimes even be multiplied or distorted. Extreme cases known as Fata Morgana occur when multiple inversion layers stack, creating complex, layered, or stretched images. And you don't need to trek to the desert or polar seas to see light bend. You can recreate this experiment at home or in a high school laboratory. Using a laser pointer, 5 mm, green preferred, handled with adult supervision, 2 transparent bottles, milk, and table salt or sugar, you can create your own artificial mirage. Here's how. Prepare a saturated sugar or salt solution. Keep adding until no more dissolves. In 1 bottle, adding a little milk for visibility. Fill a second bottle with pure water plus a bit of milk. In a rectangular transparent container, carefully layer the denser solution at the bottom, then float the lighter solution on top, using an inverted spoon to minimize mixing. In the homogeneous middle layer, the laser beam travels straight, but at the interface, where the sugar gradient creates a difference in refractive index, the light bends. By shining the laser at different heights, you can observe the ray bending most strongly where the density gradient is greatest, just like in real mirages. Safety instructions. Always use a laser pointer with power less than 5 milliwallers. Never point the laser directly at anyone's eyes, including your own. Wear appropriate laser safety glasses when operating the laser. Conduct the experiment under adult supervision. Avoid shining the laser towards reflective surfaces that could redirect the beam unpredictably. Thanks for watching. We hope this journey into the science of mirages has opened your eyes to the fascinating ways light interacts with our atmosphere. Have you ever witnessed a mirage in real life? Share your experiences and questions in the comments below. Don't forget to like, subscribe, and hit the notification bell to stay tuned for more science adventures. See you next time.